Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Okay, yes, tonight we are looking at this question. It says that define power and give its SI units. Okay, what is power? Power is defined as the rate at which work is done, the speed at which work is executed. That's power. So that is that. But here, before we leave this question, I want us to look at some basic expressions for power. Okay, I want you to know that every time you have the aspect of rate, you as a scientist, what comes to your mind? That there is an aspect of time. So in other words, we can say that power is equal to work over time. But you have to remember that work is a brother to energy. So we can say as well that power is equal to energy over time. Okay. So if it's energy over time, then we can also say power is equal to change in kinetic energy over time, because that's energy. Or we can say power is equal to change in potential energy over time. Or we can say power is equal to change in kinetic energy plus change in potential energy over time. But I want us to look at one basic expression for power, which you as a student cannot miss. We know that power is equal to work over time. But during the time when we are covering work, we saw that work is equal to F delta X cos theta. So if the force under consideration is in the direction of displacement, we can come to this expression that work is equal to F delta X. So if that is true and that is the case, we can come here and say power. Instead of work, we can put F delta X over time. Now, if we split this one, we can have force times displacement over time. But during motion, we saw that displacement over time is velocity. So what you have here can be substitutable with the V. So this expression can become power is equal to F V. But you have to remember that this expression is used for only one force. And that force is supposed to be applied force. So all in all, we can come to the expression that power is equal to force applied times velocity. Under which circumstance do we use this expression? When the body is moving with uniform velocity. Yeah, so comes this question. It says that a 1,000 car accelerates from rest to a speed of 25 meters per second in 10 seconds. And the question says that calculate the power of the car. So when you look at this question, what do? Look at what is given. We have a mass. Yes. What else do we know? We have the initial velocity. Rest means 0 meters per second. You have the final velocity, which is 25 meters per second. You have the time, which is 10 seconds. So when you look at this information, where does it lead us to? It leads us to this expression. What does it say? Power is equal to delta EK over delta T. Okay, if that's true, let us expand delta EK. Power is equal to a half mvf squared minus a half mvi squared over delta T. Okay, if that's the case, then we can substitute in. And we are going to have, which is a half. Do we have the mass? Yes. The final velocity? Yes. And it is squared. Minus a half times that times 0 squared. All this one over 10 seconds. Yeah, what you get out of this one is going to be our power. So there we are. It is 31,250 watts. That's the power. And with that, we'd like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. We are not going to get tired of reminding you to subscribe, to comment, to like, to share. Yes, we are simply the best. See you then. Bye-bye.